Hi, hello everyone. I'm Dr. Prasad Pudil. I'm covering the video classes of biology for engineers. Chapter 3, fourth topic, skeletal system as scaffold. So this is under the subject of biology for engineers with a common subject code of 21 BE 45 for all the four semester of with you. Okay, so from past 2 3 days, I was not uploading the video related to this one. I was busy with some other official work. So lot of inquiries came. I think they feel I what I explain and it's just like a story. They're waiting for the next story, next part of the story. So which makes me also excited. So whenever getting free time, I'm preparing the continuity notes and making the video presentation here and uploading to my YouTube channel, My Intuition. Uh, for my effort, please do subscribe to my YouTube channel, My Intuition. Uh, Watch this video completely. Share these videos to others. Very informative materials I am collecting with all the research papers, all the help of a new technology. I am getting the study material collected and I am presenting it here. Whatever topics or terms which is feels tough for me, I am converting further. I am developing it and giving the complete note which are possible on the given syllabus. Okay, so this is for chapter 3. Chapter 3 means module 3. Chapter 3 written because I'm converting it as my textbook. I almost finalized it. A few modifications, few confusions I'm avoiding, which will be useful for me as well as for my students who are watching this or through my YouTube channel. Because so many students I have right now, not only a very few. I'm not handling the subject in my institution, but still it's very interesting topic for me, and it will be my 25th textbook also. Okay, so skeletal system. Before that, we should know what is scaffold, which is already I explained in my previous video. That is muscle system as scaffold. Scaffold is a structural thing what we call, which is used as a support for the growth or as such mechanical support it will give. So scaffold, to say what is skeletal system, how it is used as a scaffold. First, we should know what is skeletal system. Just brushing up our information or our knowledge on bonds. What are the bonds? Bonds everyone knows. What is a bond? Bond, it refers to the framework of the skeletal system. Actually, it is the framework of bones, joints, and connective tissues which provide structure, support, and protection to the body. The key components are bones, cartilage, ligaments, tendons, axial skeleton, appendicular skeleton, joints, different joints. Okay, so we'll check one by one very slowly. This is very introduction to this particular chapter, but this is very important. Once we understand this, then only we can apply our own knowledge of any other different field of engineers can think about their alternate their ideas. They can connect it to this particular topic. Okay, so this particular subject, it is given for all the engineers with this same intention. I feel so that we have to find a now alternative solution. We have to have something, do research by using the engineering knowledge, connecting to the biotechnology field, so that new things are already coming up, but speeding up it up and giving a uh, new heights to that. We have to introduce these biological terms, biological things to all the engineers during their engineering career itself. Their professional one, they're starting their professional career from engineering stream. Okay, so the bone, the skeleton, the schematic representation of a bone is given here. So this is the representation. It's a small part, cut part of a bone piece. A bone piece many have seen. If you cut, you can see different uh, things inside that bone. It is a bone itself, which has got a ligament. It has got a cartilage in between. Okay, so this is the representation of bone. So bone, it can, our human body consists of around 206 bones for a normal person, uh, and which vary in size and shape. Bones are composed of hard and dense connective tissues which provide strength and support. They serve as the anchor points for muscles, protect internal organs, store minerals like calcium, phosphorus, etc. 206 bonds only. Okay, don't go for fight, don't go for fast bike riding, don't break your bonds. It will not become 207, always it will be 206 only. Don't think that I need one extra bond. Don't try for that. 206 is the fixed one for a human body. Okay, other than that, if it is there, that will be an extra which is not having a useful function right now. Okay, so cartilage is a flexible connective tissue which is found in certain joints and structures such as ears and nose. It acts as a cushion between bones, uh, reducing the friction and absorbing the shock. Okay, so that is the use of cartilage. It is a flexible part of a bone. Ligaments are tough bands of fibrous tissue that connects bone to other bones in joints, providing stability and preventing excessive movement. No complication. Tendons are the strong fibrous tissue that connect muscles to bone. Okay, so ligaments are the one which connects bone to bone. Tendons are the one which connects. It's a fibrous tissue which connects muscle to bones, enabling movement by transmitting the force generated by the muscle. So it is represented here. So this is the tendon connecting to muscle. There are this is the bone as such. Okay, there are two types: axial skeleton and appendicular skeleton. Axial skeleton represented here. What is smiling face? Appendicular skeleton is also represented here. Both has nothing to do. Okay, you people study. Okay, they are standing there. You can study us. That is the expression that they are giving. These two persons giving. Okay, representing axial skeleton and appendicular skeleton. Okay, so the axial skeleton forms the central axis of the body and it includes the skull, vertebral column, the rib cage. Okay, so we know what are those things, the names. The skull, head, what skull, vertebral column, the back side, the column. Rib cage covering our heart, lungs. That is a rib cage. Okay, appendicular skeleton, the remaining all which covers the skeletal part, we call it as a appendicular skeleton, covering arms, upper arm bones, forearm bones, legs. Okay, that is very easy to understand. Or upper limbs, humerus, radius and ulna, hand bones, limbs, femur, that is thigh bone, fibula, that is lower leg bones, and foot bones. Okay, so first we can see say that the other arm, upper arm, forearm, legs, uh, hand bones, thigh bones, lower leg bones, foot bones, it comes under the appendicular skeleton. Joints. Okay, now there are so many joints you can see. Okay, where the bones meet and allow for their movement. There are different types of joints, including hinge joints, there is elbow knee, then ball and socket joints. Okay, the hinge joints, elbow and knee, which enables bending and straightening. So this is that. Okay, ball and socket. No, hinge joints. Hinge joints. Where is hinge joints? B. Okay, so this is the hinge joints, which makes the bending and straightening. Ball and socket joints, hip and shoulder, which allows for a wide range of motions. Full rotation. Full rotation is possible. So that is given by the ball and socket type. Means full rotation. It is. Okay. So that is the ball ball and socket joints. Okay. So now you can understand the word pivot joints, etc. So the different the physical appearance as well as the original one both are given here for comparison. The first one, that is this type of movement. Second one, that is moving in between this rotation. rotation between, just like ball bearing. This is humerus, just moving up down movement only. This third one, B, that is pivot only, this movement. Okay, the movement, not full rotation, little bit rotation is there, not too much friction is not, this one is not there. Then last hinge, which is on our leg part joint. Okay, I'm not lifting my leg and showing. Leg where it comes there, that joint that covers. Okay, so different parts, the different fingers in between. Wherever possible, you can think what type of joint it is based on the movement. Based on the movement, we can this we can see what type of joint, bone joint is there in our body. Okay, so better to do all those check, become an exercise also. Okay, so usually we won't do exercise, at least you check all your body part, rotate it, move it, and check what type of joints is bone joint is there. Okay, then we'll move on to the scaffold. Once you understand the different joints, then only you go to the next topic, scaffold. Till then, keep on doing the exercise. If you're tired, then you can come back and join this scaffold. Okay, skeletal system as scaffold, just like muscular system as scaffold. In muscular system as scaffold, in the previous class video, I explained that we use hydrogels or other artificial scaffold to that muscle tissues are added and it is grown, or even the muscle as such, the muscle structure, the muscle cell as such, it is decellularized, removed things, then gives the skeletal things. To that, another tissue it is added, another cell is added, it grows and becomes a tissue. Same way, skeletal system, usually when there is a problem for the bone or the skeletal system, mainly we call it as bone, that is easy to understand. If any damage happens in the bone, inside the bone, or any bone thickness reduces, this is for older ladies, grandmas, and they feel bones are very weak. Always they feel bone, they get the bone fracture things. Such cases and all, that means we need to replace the tissues. The tissues growth is hindered, or the tissues are not sufficient, or tissues are not working the function which is supposed to do. Such type of cases, we can think about replacing it. So we need to grow tissues which is needed there. Okay, so the same cells you have to take and you have to grow extra growth. What required growth you have to do. For that, either we can use artificial scaffold, or even we can think about the skeletal system, the bone itself, the the hole present inside that bone itself, we can use as the scaffold. So that is explained here. Okay, so both is in two paragraph it is explained, not given in detailed explanation. Either we can use other scaffold and replace the bone defects, or even we can use the bone tissue uh, by decellularizing the bone or cartilage scaffold as template and drawing it. So it is very important to note that using a skeletal system as scaffold for tissue growth requires careful consideration and modification. Incorporation of bioactive molecules, cell seeding are necessary. Okay, this is skeletal system. Okay, okay, the cat is crying too much. Okay. So bioengineering solution. Now some sound disturbance. That is my home cat. Something happened to the baby cat. Okay, I'll try to pause the video and go. But where is the pause option? Okay, there is no pause option right now enabled into this system. Okay, so osteoporosis. Osteoporosis is a condition which weakens the bones and makes them more likely to break, fracture. Okay, so simply explain. This is the natural healthy bone if it is. Then osteoporotic bone you can see the density is decreased, the number of cells tissues present it is less, and slowly it becomes it may fracture or crack happens. Okay, so that is the generally become fragile bonds, then they are prone to fracture. Osteoporosis is a common condition among older women. It may be due to the older age or with the family history like smoking, excess drinking, alcohol, or becoming a very small body frame or having low calcium intake. These are all the causes, said causes for osteoporosis. Medication or the prevention, medications are there like bisphosphonates, a chemical means drug which is used, denosumab, teriparatide, some of the medications. Okay, doctors knows better than us. Calcium and vitamin D supplements, calcium supplements that we know general cases. Vitamin D supplements also we know, so we should supply these for such type of persons. Exercise, weight bearing and resistance exercise means small exercises always make the bone density high. Lifestyle changes, quitting smoking, reducing alcohol consumption, eating a healthy diet, which includes calcium and vitamin D also helps. Bioengineering solution for osteoporosis, tissue engineering. Tissue engineering in which this scaffold system mainly we use. We use either artificial scaffold to grow the bone tissues which is damaged and replacing, or we are using the bone structure as such scaffold and making the tissue to grow. Both cases are there, that is called as tissue engineering. Stem cell therapy, stem cell I think uh, the uh, not explained in this video. Okay, okay, stem cells are the cells which are similar to the normal cell. Our body biosystem, the human or animal living cells, living body, it consists of two different types of cells: normal cells which do the normal function, as well as some backup, that is stem cells, which is there in our body. If any damage happens to the normal cell, immediately the stem cell will go and replace and take up the role. They will become the normal cell. Okay, so that is stem cell. Identifying the stem cell, it is very easy for a biotechnologist using the available instruments they have or the available methods. They will identify the stem cells, and these stem cells are used for replacing the damaged cells, either from their own body or from the donor's body. Biomaterials, they are also used to replace or augment damaged bone tissues, which will function as that of the bone. Many materials are there, uh, which I will explain. The next page it is there. Okay, so gene therapy. Gene therapy means a cell has got a gene. The gene is doing the function. It is making the cell to multiply to the another cell. So many cells, combine tissue, all those functions already you may be knowing. So sometimes the damage happening may be due to the mutation of the cell. Mutation of the cell means if some the environment changes, or if any external virus or fungus or say microbes comes and affects the gene, mutation takes place. Mutation takes place means it get converted into some other start giving some other function, so not giving the normal function which it has to do. Therefore, a cell, if the cell is not having the required gene, then we have to inject a gene to inside that cell, so that then the gene will further do the work. Okay, so that is called as a gene therapy. Then artificial bonds. Artificial bonds are made up of bioceramic or even polymeric materials. Ceramic materials like hydroxyapatite HCl are used. Okay, example is given here. Tricalcium phosphate is also used because they have good biocompatibility. Yeah, biodegradability is also good. Bioactive glasses like silicate based glasses are used. as an artificial replacement of bonds, which we call as the artificial bonds. Even polymers also used, like polycaproatom or polylactic glycolic acid or polyethylene glycol. These are also used wherever possible to replace or to support the bond system. The advantages of artificial bonds: they are highly durable, customization, reduce the risk of rejection, fast recovery are the main advantages of this type of artificial bonds which we use. However, there are some potential drawbacks to artificial bonds, such as risk of implant failure, long-term stability issues, and the need for additional surgeries in case of implant wear or damage. Okay, so that's about a skeletal system and scaffold. So I revise once again this particular topic. It's actually a subtopic. The third topic actually it is the muscular system as well as skeletal system as scaffold. But I split into two: muscular system as scaffold. 4 or 5 pages notes I prepared that I made as one video. Skeletal system as scaffold just now covered, in which I explained about the skeletal system. Okay, the main coverage maximum goes for the introduction. Without introducing straight away going to that topic is may not be easy for many students which are not came from a biology background. Therefore it is introduced like that initially: what is bone, what is skeleton, all those a rough idea. Now you are able to understand because you know most of things, words you might have heard. Just rewinding it: appendicular skeleton, axial skeleton, the different type of joints, then exercise related to that, then what is scaffold, how the skeletal system has scaffold, how the normal bone, if any damage is there, how they are curing it, how the bone itself can be used as a scaffold for that cure, that is explained in this paragraph. Then what is this disease known as osteoporosis? What are the treatments for the osteoporosis? How to manage it, the osteoporosis? The engineering solution, that is mainly tissue engineering, in which this scaffold concept will come. Then stem cell therapy, biomaterials usage, gene therapy, all those are also explained. Then explained about the artificial bones, replacing the bone structure as such, replacing it, not curing. Cut, remove, and cut paste the bone, like with the ceramic or uh, polymers is explained. I think this much is enough for this particular topic. Whatever required I added to it. So hopefully it helped you a lot in understanding this particular topic. So now any question asked based on that, you can write something, some points you can write based on that. So I'll be very happy to know if you subscribe to my YouTube channel, uh, put like button there, share this video to others. So once again, thank you very much for watching this video.